corresponding points on adjacent waves.
What if we just put 2 points?
All right, 2 points on adjacent waves. Do they have to be corresponding, or can we go from a crest to a trough? Okay, it has to be a corresponding point. What's the unit for a wavelength?
Meters and nanometers.
You could have said meters or nanometers. And what's the symbol?
It looks like a
All right, it looks like a stick. What's its name?
lambda.
Lambda. All right, what is frequency?
Number of waves that pass through a given point in a given amount of time.
The number of waves that pass a given point in a given amount of time. What's the unit? Hertz. And what's its frequency? It's italicized V. Now, I did forget to tell you the definition for Hertz yesterday. So if you got your notes handy, let's add that because I forgot it. Hertz is defined as 1 cycle per second, which is basically one of those, but it's 1 cycle per second. Okay. Everybody add that to their notes. Caleb, did you find it? I did. You got to redo it by Wednesday, or you can't do the lab. Okay? And I will change it when you redo it on Wednesday. Because you got to have that piece to do the lab. All right, number, where are we at? 6. How are frequency and wavelength related? They're inversely proportional. What's the color and frequency of light if we have 585 nanometers?
Yellow.
All right, yellow. Okay, what's the question? Okay, go back to number 6. What's the?
Can we put that one decreases, the other decreases?
Yes. Okay. You might also need to know the math term, though, so make sure you know both. All right, so is everybody okay with yellow?
Yeah.
All right, and what is the frequency? All right, so for those of you who weren't here, C equals lambda nu. C is 3.00 times 10 to the 8. We have to take the 585, which is in nanometers. We have to change it to meters. That's a 1. Nanometers is 1 times 10 to the 9th. You have to learn that number. That's going to give you 5.85 times 10 to the negative 7th. That is your wavelength. It goes there. Solve for your frequency. Divide both sides by 5.5 times 10 to the negative 7th on both sides. And what did y'all say frequency was again? 10 to the 14th, and that unit is hertz. All right, everybody good?
That was homework. So
Okay, that was the same one on the homework?
all those other questions.
I know. Yeah.
Oh, yeah.
When you look at the numbers, I feel you on that. All right, so when you look here, your 5.85, this is a number line. All right, this is 5.7, that's 5.9. Where does 5.8 sit between? It sits between there, so that's why it's yellow. Okay, does that make sense?
Yeah.
Okay.
I almost put green. I meant orange. Yeah.
All right, orange would be higher than 5.9, so that's why it's not orange. Does that make sense?
Yeah.
Okay, and you use the wavelength to find that number. Any questions on the opening?
So.
All right, are we good? Can we look at homework real quick? All right.
Are you checking it?
I'm not checking.
No.
I already said I'm not checking. I don't care what half the class means. Where else am I missing?
You do everything?
No, 1 through 11.
1 through what?
11. Did I get everybody now?
Let's check it.
All right, so number 1, we just did 2, 3, 4. What 2 properties identify all EMR? Wavelength and frequency. We did 5 and 6, except for drawing an example. So in 5, if we drew an example, there's a wavelength. There's a wavelength. You could even start here and go here. That would be a wavelength. If I put a time on it and I said 1 second, how many waves do I have? 3. So 3 waves over 1 second would be 3 hertz. All right, that takes care of the 2 parts we didn't do in 5 and 6. We did 7, 8. We would have, whoops, too far. 6.70 times 10 to the negative 7th, which would put us here. It would make our color red. And then when we calculate our frequency, what would we get for our frequency? Anybody tell me? Or do I need to calculate it? I could just find the answer key, but that would be too hard. 4.4 times 10 to the 14th. There's your frequency. All right, from there, 9, the speed of light is 3 times 10 to the 8th meters per second. Number 10, what's the electromagnetic spectrum? It shows all types of EMR. How do we determine the type of EMR? How do we determine what type of EMR it is up there? It's wavelength. And what's the photoelectric effect? Yep, the emission of electrons from a metal when light shines on it. Everybody got it?
Fabulous. Took your word, Daddy.
I'm good with that. Fabulous works. Did you find it? Put it on my computer. I'll take care of it during the quiz. All right. You need a calculator, your orange chart, and a pencil.
No idea.
Is it giving matching?
And I'm going to hand it back to you because you got to keep it Wednesday. There's no magic. It's all through response.
Are you serious? How many questions?
I told you this yesterday.
No, questions. You don't
They're
like
10.
the way I work things.
And I made it really easy because I thought about y'all this morning and I was like, let's make it easy.
Yeah, all right.
I did. I even revised it and made a fresh one. I don't even have an answer key. I got to do an answer key.
Take your word. I just know you don't like the way I work things.
2 corresponding.
That's just something like I in my mind.
I don't like how we
I don't care. I got other ones I can give y'all. You take it or bring it up. Works for me. I got harder versions for y'all.
Wait a minute.
Yes.
Wasn't very catchy.
Hurry
Oh, I need one for the key. What was I thinking?
Is this yours?
Yep.
It's the original.
Yeah.
Well, let me borrow one of our sheets.
Tomorrow, she.
Do what?
I'm sick of saying.
Oh, no. We're not sure how to explain the photo like it was like
You can draw the picture, but it will not get you full credit. Read the definition.
I knew there was a reason I like Chiefs. Or the gas. No, I
I
killed
gave
off,
one to Duke to the window. I delivered one.
I killed an entire ream of paper in here. It's like,
You need more paper?
no, I'm good.
I'll bring you some, I'll bring you some information.
That'd be great. It's just stupid.
I know.
No. Say what?
You should.
Yeah.
That's fine. Don't mind me.
We almost done? We should be getting pretty close here. All right. Anybody still working now? All right, past papers to the front. So if I've stapled all the progress reports together, put in grades, and done the answer sheet. You've had plenty of time if you know what you're doing.
I'm just tripping over a question now.
Grab plates. All right, find your notes. I'm gonna bore you to death the rest of the period. Probably not. Won't make it. It was a pipe dream when I wrote it up there. Put it this way. I didn't even load it in up because I knew it wouldn't happen.
What do you?
I do an endo and exothermic lab.
That's so. That's didn't like know how to answer.
I think that's the one that's like.
Yeah, I just.
Because I thought it was if one thing is decreasing the other, it's decreasing. So this has shorter wavelength, then the higher frequency, right?
Yeah.
I think
That's
put it in the
what I thought.
calculator. I did the 3.5. It's 5, and that's what I'm like. But
What are you talking about?
what has the highest frequency?
If it has a long wavelength, it has a. If it has a long wavelength, it has a. Remember, they're opposite, right?
So we did get it right. So the highest frequency is this.
Really?
What? Good job.
You could be if you got them right. Did you pay attention yesterday? You know some stuff.
That's the one I was tripping over because I put gamma first, and then I was like, wait, if this is negative, that means that number's the lowest. And then I was like, wait, radio.
So do we need to talk about that?
Myself.
I'm so
Like, you're gonna see on my paper, gamma waves, and then when I said I'm tripping over a question about because.
So do we need to talk about that?
Yes.
Okay. Let me pull up the chart. It's in here.
Because
Wasn't it like one? But didn't they ask for like the color and the frequency? They asked for the color and the other one.
didn't ask you this story.
So like, do you have to like violet
All right. So if you look at the chart, and I don't remember which question asked what, but one of the questions asked for frequency and one of the questions asked wavelength. Okay. So if I ask you which of the following has the highest or lowest wavelength, the chart reads wavelength. Okay. So if I say which of the following has the shorter wavelength, all you have to do is look at the wavelength arrows. Okay. So I can't remember. One of them said which one has the higher wavelength or longer wavelength. So longest wavelength would have just been what? Radio waves. Okay. Because I just said wavelength on that one. Now, if I said which color has the longest wavelength, it works the same way. You just look at the colors and which one has the longest wavelength. Red. Now, in one of them, I asked about frequency. All right. And I said, which of them has the, let's say, highest frequency? I can't remember what I asked, but because I'm getting old. Huh? Yeah, I'm sure.
look on the quiz and be like,
Well, I don't remember answering that question.
I'm pretty sure it was 9 and 10. One of them was about wavelength. One of them was about frequency.
go read it.
And I looked at it, but I changed my
What color was the highest frequency?
I know I missed that one.
All right. One of them was highest frequency.
What?
I don't remember if it was color or the thingy. It was color. All right. So yesterday, what did we say about wavelength and frequency? They're inversely proportional, right? So where it's a long wavelength, remember they're all stretched out. So what does that say about your frequency? It's a low
Serious?
frequency.
Oh
And
my-
where it's a short wavelength, the waves are really close together, so it's a high frequency.
I literally
Okay?
hate myself. Now my brain is going to go to.
So who would have the highest frequency? I'm pretty sure this was the color question.
Yes.
So which one would have the highest frequency? Violet would have the highest frequency. But if I had said this, you would have picked what? Gamma rays. Now, if you've written it on your orange sheet, you need to get a different sheet on test day.
Okay.
You need to borrow one from me. That is not to be written on those sheets. So if you wrote it on there, you need to borrow a new one. Okay? This that I just wrote up here in red should not be written on your orange charts.
What was the answer for
Okay? What?
What was the answer for the wavelength one?
What? Just what is the wavelength or
No, it was.
the one at the bottom, 9 and 10?
Yeah.
It was a memory.
Number 9 said that was 10. Which type of VMR has the longest wavelength? The longest wavelength, which would point to that wave, the longest wavelength would be radio waves.
Okay, got that right. And then the color one would have been
No,
freaking violet. I know, I'm freaking kidding me. I got a probably seven. I'm probably like thinking seven.
I started panicking because she was like, okay, I'm going to get it now.
There's nothing in the question. They're dry.
Hey, you want some?
The other one was
it.
The other one wasn't.
You really making everybody today?
It's bothering them out there, regular paper in the trash can. All right, but does that make sense?
Yeah,
Okay.
so bad.
All right. Don't be mad.
So ready for this quiz.
We stopped at a quantum is a minimum amount of energy, blah, blah, blah.
Okay, we're there. Blah, blah, blah. Okay, so we're here.
Wait, hold on. Oh, there it is.
I just skip a whole page.
You go ahead and recap on whatever we just talked about.
Yeah, I'll recap in a minute.
Oh, you might have.
We just did a quiz to recap.
How much more notes should we have of quantum?
More than you want.
But I need to try this again, quantum theory. I'm starting to
Same thing.
I didn't even go there.
I know. I'm just gonna do my work. I got 3 hours of like sleep. You should hush.
Dude, I did. My mom thought I was actually going to do all my homework last night. I wouldn't know.
All right. So going back, particularly for those people who are not here, so we can recap where we were yesterday.
Where did we stop off at? What color frequency of light?
There.
We stopped there for real?
Yep.
Yeah. I don't think I wrote photo.
I love that
All right. So for those of you who asked me about the photoelectric effect on the quiz, you needed what's in green, essentially for full credit.
Yeah, got that wrong.
Alright.
Like,
And you did. I'll read your answers. I don't want to hear what you wrote. Okay. Don't ask me a ton of questions. All right. If you said something about electrons being lost from light hitting a metal, if you had those 3 pieces, then you will probably get credit. If you did not have those 3 pieces, you will not get full credit. Okay? Light has to hit a metal and electrons have to come off. If you do not have those 3 parts, you will not get full credit. Okay? I don't even hear your answers. I will read them later. Sometime this weekend or Monday, I will try to get to them.
We write this down.
Now, I'm not going to give you enough time, most likely, to get it all written down. So don't be mad if I move on. Now, it's on the video. If you've been writing and getting it, fabulous. Now, the photoelectric effect refers to the emission of electrons when light. So light's going to shine on a metal. It's going to hit the metal, and then electrons going to come off. Now, the thing that we talked about yesterday is, does all frequency of light hitting a metal cause this to happen?
No.
No. Current wave theory of the time said yes. So even these light bulbs would cause this electron to come off. Now, we all are bright enough to know that these light bulbs in here are probably not going to cause that to happen. So, scientists know that only certain frequencies are going to cause electrons to be knocked loose from a metal. So, German physicist Max Planck proposed that energy is not released continuously, but in small packets. So I drew a picture yesterday that sort of showed little dots striking the metal. And then an electron was released. Now, he called these little packets of energy what? Quanta. Now, quanta is plural for all these together collectively. Okay? Now, a singular burst there is called a quantum. Okay? One is a quantum. Now, this quantum has to have a minimum amount of energy to cause an electron to be lost or gained. Okay? So if this little burst of energy right here does not have this minimum amount of energy, is this electron going to be knocked loose from that metal? No. That's where we were yesterday.
Wait, what's the little bitty ones
Wait,
called?
you said this.
Quantums.
And then all together they're called
Quanta.
Okay.
Do we need everything on this page too?
We already have everything on this page.
Okay, wait a minute.
No. That's all in the video from yesterday.
Right, I was gonna make a think.
Oh, okay.
Nah.
Okay. Now, so this is where we were yesterday, or where we're starting from today. So a minimum quantum of energy is needed to eject an electron. Okay? Some minimum amount. This minimum amount is called a quantum.
Okay.
What's your favorite food?
I don't really have one.
What? All right, what's something that you don't eat then?
That I don't eat.
Pickles.
Like you despise it.
Don't care for Brussels sprouts.
Me either.
I don't like most greens, like collards, turnips.
Oh,
Me
that's
either. Right.
I hate fish. Fish is so.
I can eat certain types of fish.
My favorite is a crab. By far.
I love crabs and cases.
But it's good.
You probably got a t-shirt cut.
I'd rather have shrimp than crab, but I will eat crab.
Crab is delicious, especially when we make the correct sauce for it.
My dad loves making crab cakes. I love when he makes it.
I don't care for crab cakes.
Oh,
My
my
mom
mom
loves Missy crab cakes.
All right, so Planck also proposed a relationship between energy and frequency. You guys are not going to have to calculate this. All right, you do have to know the relationship, but you don't have to calculate it. So we've just talked about energy and frequency. So energy and frequency are given in this equation. I want you to notice how this is different. Okay? In this equation, C equals lambda nu, we're on the same side, right? And what was the relationship when they were on the same side? What was the relationship between wavelength and frequency? What was the relationship yesterday?
Opposite.
They were opposites. What was the math word we used for opposites? All right, so they were inversely proportional. Okay? And I want you to notice they're on the same side. All right, now, notice where energy and frequency are this time. They're on opposite sides. Do you suppose they're inversely proportional this time?
They should go hand in hand.
They are. They're directly proportional. Okay? Okay, now, I pulled it down too far. All right, this time, it's on the next screen. They're directly proportional. Now, E stands for energy, and it's sort of the universal symbol. V is frequency, which we already know. Now, you do not have to write this down, but H is called Planck's constant.
Do we have to memorize that number?
No, you do not. All right, I only have it there so nobody thinks I made this up. All right, it's a giant, well, it's actually a really, really tiny number. All right, we are not going to calculate with that number. For those of you who one day have to have science or a chemistry class for your degree program because you're majoring in something that requires a chemistry, you will have to calculate this most likely in college chemistry. We are not calculating it here, okay? You don't even have to write it down.
He put that, Miss Law, he actually, whenever he was helping me, like, he put that as Avogadro's number because he didn't memorize, and that ain't it.
Okay.
Scared me. I was like,
That's why I said, if you take college chemistry, you will have to use this. We're not going to use it. There's a day when I had it memorized too. Those days are long past. All right, can I go?
What's the JS?
Joules per second.
Joules per second.
Joules seconds.
Joules per second.
All right, so what did we just say about energy and frequency? How are they related?
Inversely.
No, we didn't.
They're hand in hand this time.
All right, so they're directly proportional. So what happened yesterday when we said inversely? Inversely, if one went up, the other went down. So what are we going to say for directly proportional? That's right. All right, if one increases, the other increases. All right, so that's energy and frequency. Say what?
It's not even 11 o'clock yet.
Nope.
Oh my god.
I've only been talking like 10 minutes, so chill over
It
there.
feels like forever. It
Right.
does.
Oh, this class goes by the slowest.
I am so sorry. I could say I cared, but I really don't.
It's okay, we don't bother.
Wait, I wasn't
Dude, there's like 10 words on this slide.
I'm not sure.
Right, I'll just be about it.
If y'all hate this, I'm so looking forward to the quantum numbers. All right,
It's just boring.
and I will warn you, the quantum numbers is one of my favorite topics.
Wait,
Now, Albert Einstein. Yes, the same Einstein y'all always heard of. All right, explain the photoelectric effect by proposing that light is a stream of particles. Yes, this will all be on a quiz on Monday also. All right? And it can be viewed as a stream of particles. So the more you talk and interrupt, the less you know on the quiz.
So we didn't know what Albert Einstein is.
Okay.
Make it multiple choice, dude.
I don't do any of this as multiple choice.
I was about to say something.
Yeah.
I don't like studying hard on being treated differently.
All right, so he's suggesting something very similar to Max Planck, that the photoelectric effect be viewed as a stream of particles, okay? And each particle carries that minimum amount of energy.
Are we getting close to the test that we do test prep on again?
No, that's in second quarter.
Well,
That's-
this will be
that's
a
next
Bonding
week,
in the
so-
periodic table.
We're not
We got a test on Monday, right?
We have a quiz.
Oh, next site. Sorry.
Let's say no. All right, so again, Einstein is just like Planck in that he's got a stream of particles. Okay? Now, each of these, use a different color, carries a quantum or a minimum amount of energy. Okay, does that make sense? Now, since I had that picture there, they would all be a quanta, because quanta is plural. And again, that stream would be striking a metal to hit and knock an electron loose. It's refreshing.
It doesn't feel like they're there.
Quanta is just plural for quantum. Yep, for one particle. Quanta is multiple particles.
I feel like I've been paid a long time. It's been days.
All right, everybody there?
Sorry,
No.
You said no.
I did, but like.
All right, so from there, this one I'm going to alter.
And what's going on then?
Cause it just moved too fast. I didn't want to.
We don't need any of that zero rest mass crap. Don't need to know it. The grammar's probably off a little bit because I just altered the
Yeah.
sentence.
Are we gonna need
Right.
to know all this background information?
Yep. I told you. You're getting extra here because you're what? Yep. And on Monday, when we do the quantum numbers, I will go so far over the top it will nauseate you.
What, how should we write this? Not like the way it's worded.
Each particle
Just
that
alter
carried
it
a
to make it
quantum
fit.
Then I'll change the whole thing away.
You can change it any way you want to.
That carried a
That carries quantum of energy.
That carries. Change the of to that. Really? You couldn't do that? What English are you in?
Mexico.
I just took 3.
Not yet.
And you can't change it up to that?
I don't want to mess anything up.
So, essentially, Einstein's giving it a new name because he's a different scientist, so he's giving it a new name. Scientists like to do that, okay? So, a minute ago, when I drew the picture, all right, I don't have anything there, so I've got a lot of space to draw. All right, I drew this, and I said
A futon.
that this was a quantum, right? Or I said it was a particle that carried a quantum of energy. Right?
Right.
Now I can call it a what?
Photon.
Okay? That's what that means. That's all that means. Einstein says that any particle that carries a quantum of energy is called a photon. So,
Photon.
it's not a futon, it's not a couch. It's called a photon. All right? So, all of these photons are going to hit the metal, and if they have a quantum of energy, then we will have an electron that comes off. Okay?
Right.
What do I have next?
So the stream of the particle, okay, there's a stream of light that hits the thing, that hits something, that hits the metal.
There's the metal. Yeah, that's the
And
metal.
those little bitty streams of particles, which are photons, and then once it hits it, it's called an electron.
Well, once it hits it, if it has a high enough frequency or enough energy, then the electron will be emitted. But if the frequency is not high enough or the energy is not high enough, it just bounces off. Okay, there are requirements for that electron to be emitted.
So this whole time we're talking about metal.
Metal, hitting a metal. Now, the next slide is what Nylasia just asked. Okay? So, what's required in order for this to be successful. Okay? You gotta have what?
Amount of energy.
You gotta have enough energy. Okay? What color am I in? I'm in orange. Okay? You gotta have enough energy or frequency. Because remember, these are directly proportional.
Oh my gosh, I can't get nothing right there.
They're the exact same word.
They're the exact same thing. So, in order for that electron to be able to be ejected, the energy has to be high enough or the frequency has to be high enough. You can say it either way. If the frequency's not high enough, it means the energy's not high enough. Okay? They're one and the same.
So can we put like, in order for an electron to be released and then the energy of the.
I don't care.
I'm just making sure.
Chill out, chill out.
I'm just looking to see what's next.
Dickory.
That's the same thing we already wrote. I don't care if you write that. It's the same thing. Are you caught up or do I have time to trim a hangnail?
You got clippers?
On my car keys, yeah.
Bruh, I'm always struggling with my nails, and so I was in here the other day, like, thinking at them, because it would not come off. Well,
I keep them on I've kept them on my car keys since I was in high school.
well, we better. I need to feel better. Boy, give me I better come back. Look to the side.
I will after this.
I know, it's like she's special.
You need to go to the office. Taylor, you still have me.
All right.
Miss.
Second one. Here we go.
All right. So this slide is basically a summary. So if you understand what's going on, you really shouldn't have to write this. Okay?
Isn't it?
This is just a summary of everything we've done. Okay?
So I didn't have to write the last one.
No, not if you understand.
Well, can I write this one? Because I didn't have time to write the.
Then yeah, you should be fine. So in order for an electron to be ejected, all right, what has to happen? A metal has to do what?
Wait, what?
In order for an electron to be ejected, what has to happen?
Must be struck by a single.
All right, it must be hit by a single photon, and the photon has to have what? Okay, you can say a quantum of energy. So this minimum amount of energy right here could just as easily have said a quantum of energy. Okay? That's what's required to knock it loose. Okay? So in order to knock an electron loose from a metal or to be ejected from the metal, it has to be struck by a single photon. That's a single one of those dots that I drew. All right? And that has to have a minimum amount of energy to knock it loose. Now, when we say a minimum amount of energy, we could just as easily have said a high frequency. All right? All of those words are interchangeable because you have to have a high enough frequency all right, let me text my husband back real quick.
How long have y'all two been married?
19 years this summer.
What did you eat for supper last night?
Spaghetti.
Dude.
Oh my God, same with my parents. What date is y'all's?
I am exhausted.
Hello?
What? Sorry.
What's your wedding anniversary?
June 24th.
My parents are July 6th, and they'll be 19 years.
How do people not remember?
And then they had a kid.
And then they had another one.
And Mary Lloyd is older than you.
Yeah, that's right. So y'all waited, they did it. They went right into it. And then not even a year later, here I'm not, so.
Okay.
364 days apart, Irish twins. I'm July 23rd, 2002, she's July 24th, 2001.
I'm guessing that, maybe some birth control didn't work out real well.
No, my mom was on the shot with me, birth control with Mary Lloyd, and, the rubber with Abby, that's what they said.
Why are you telling the personal information? I was in there last night and I'm like, oh my God, she's talking about everybody. Your mom's would.
No, Dad says it whenever we ask, all the time, and no matter who he's in front of.
All right.
Because
So,
why are you and Mary Lloyd so close in age? And he's like,
do
nothing works.
all metals require the same amount of energy to knock their electrons loose?
No.
No. All right. Different metals require different amounts of energy.
Really?
Yes, they do. Not all metals require the same amount of energy to knock the electrons loose.
Everyone's here today. So
All right.
I'm watching it. Chef.
I'm gonna make you one.
Says he's not here in North Carolina. All right. Different metals are bonded differently and require more or less energy. Okay. So the quantum of energy will vary for each different metal. Okay. They vary for each different metal.
Does that mean that you know what, I'm not gonna ask my question. I feel like it's really hard. This is the question. I was gonna ask, because you said that it can't be any type of light or something. So what type of light does it have to be?
What type of light does it take to knock off?
Yeah.
Well, it won't necessarily be visible light. It's just got to be a type of energy that's got a high enough frequency, but it's not going to be visible light.
So
It's not going to be. It's not going to be fluorescent light bulbs.
So like a gamma light?
It could be.
Okay.
It could be, or it could be UV or IR. It just has to have a high enough energy.
Is a radio wave that be the sound?
A radio wave is going to be a sound wave, but it's moving down and going to have a lower frequency, so it's probably not going to do it. What?
What's lightning?
What's lightning? Lightning is static electricity.
I told you.
So
It's when clouds rub together.
That's exactly what I just said.
Yes. And it can be ground to, it can be cloud to cloud static electricity and the transfer of electrons between the clouds or the clouds and the ground. But it's static electricity. Yeah, when the clouds transfer electricity between the clouds and the ground, that's cloud. Yeah. No. When the clouds transfer the electrons from the clouds to the ground, that's cloud to ground static electricity transfer. And then cloud to cloud lightning is when they transfer the electrons between the clouds. You know, when you see the lightning just go across the clouds, that's that.
So what's a lightning rod?
A lightning rod is a safety feature so that the lightning hits the rod and the lightning goes down through the rod and is dispersed into the ground so that hopefully the building doesn't catch on fire from lightning. It doesn't destroy the electrons. All right, let's talk about neon lights. Yep. Now, the second thing that illustrates electrons behaving as light is neon lights, and it's easier to understand.
Separate topic.
Yep.
Y'all, what happened to Demi Lovato?
She's still
Yeah. What happened? Cause like she.
people get addicted to drugs all the time.
I know, but she
They
like
get 90%. Oh no!
But she
My
like
dad had
stopped.
to pull out the big gear. My girl said it flexed on my head.
My sister said that.
Can we write this down?
Yeah, I want you to write that down.
And so they get addicted to that, and they can't have any three.
Do we draw It's a new,
I turned on Disney Channel the other day, so just to see what's on there. And I was so disappointed. I was like, "What is this trash?"
All right. So the ugly picture is representing this, which is why I said write it down. All right. Now, we're going to talk about electrons in the ground state. The ground state is a state of lowest energy. All right. So currently, the electrons in this glass tube are in the ground state. Okay. They're just chilling, not doing anything.
Wait, there's something actually in there?
Yeah, there's electrons in here. No, it's hydrogen gas. Okay, the one that I'm using is hydrogen gas. Used to have two of them, but unfortunately, a couple years ago, I smashed it on the floor by mistake.
So you can just glue it back.
You say it like that, so if you took it and forcibly smashed out. Exactly. Oh yeah, we back.
Yes.
Yes.
Silence means yes. Right, Lola?
what?
Oh wait, I shouldn't say that. I said silence means yes, and then and then
You really shouldn't.
yeah, I did that one too. I was like, oh, rape victim. I was like, my bad, girl.
All right.
Hold on.
Now, we're going to put this doodad in here, and we're going to pass a high voltage current through the hydrogen gas. Now, when we pass a high voltage current through the hydrogen gas, the electrons are going to leave the ground state, and they're going to go to an excited state. The excited state is a state of higher energy. Now, when I say higher energy,
You don't mean high is.
that is correct. That is exactly what I was going to say, Annabelle. All right? I do not mean highest because there are multiple levels of highest energy. It may go up and back down. So, when I say excited state, let's say this is the ground. All right? It's going to go up to the excited state. And once it gets there, is it going to stay there?
No.
No, it's coming back down. When it comes back down,
It'll go back up.
it's going to go back up, okay? It might go slightly higher to another excited state, or it might not have gone up as high, okay? Now, when it comes back down to the ground state, what does it give off?
Well, that's pretty.
What do y'all see?
Oh,
What do we call that?
I didn't see that.
Purple.
I heard it over there.
Violet.
It gives off light. Now, that's what we're able to see because I can demonstrate that to you guys. Now, did I have to use just plain visible light? No, I could have used any type of EMR or electromagnetic radiation, but if I'd given and shown something that was giving off microwaves, you guys would have all looked at me and gone, yeah, right, Miss Wall, how do we know it's giving off microwaves? You're just making that stuff up, okay? So I'm using something that demonstrates visible light so you can see that it's visible light, okay? Because if I was giving off gamma waves, A, it's nuclear radiation, you wouldn't be impressed. But, you know,
Yeah, you don't be impressed by it.
all right? But UV, you wouldn't be able to see. Microwaves, you wouldn't be able to see. So I'm using something that we can see,
Yeah.
okay? Now, we don't need those lines at the top. What is emitted when an electron returns to the ground state? We've already done. We don't need that. Moving on. All right. When light goes through a prism, what do we see?
What color?
What color? I heard it. I need something a little more. All right, what spectrum? I need a name.
Visible spectrum.
There we go.
I actually we're gonna learn about this. Really good.
All right, it's called the visible spectrum. A lot of you guys will just say the rainbow, but it's called the visible spectrum. All right, we talked about how to know the order of the colors yesterday. There you go. All right, Roy G. Bibb.
Isn't that one guy, symbol?
Yeah. Yes. Now,
Yay, that's tough. I mean,
Oh, no.
dang, sis.
Yep.
Just redo it.
all right, so
If that's the case, then
Don't
how
do
do
that.
like markers?
the next question was going to ask you, how do you know what color you're going to see?
Because it comes like
Depending on the light that's on the thing.
thing it hits.
Yeah.
Because it's the side that it.
Yeah.
I don't want to talk about colors of what's reflected and what's absorbed. How are we going to know whether we see red or blue or yellow or green based on
With our thingamajigers, that
Oh,
does
well,
the equation stuff.
Yeah. Wavelengths.
wavelengths? Okay, which is what's the next question when it comes back up.
So it was called a
Visible.
Where's it?
As well, if that's the case, then how do like markers and like t-shirts and all that stuff work? Like how do you see the color?
What's shaking in there?
Touch it.
It looks like one of those things. If you touch it, like the line would go.
Huh?
If that's the case, then how does the
That-
color?
Touch it and see what happens.
If I touch it, what will happen?
That all has to do with absorbed and reflected. I'm not going into that.
If I touch
That's
it, will
physics.
the lines come to me like in those little
No,
balls?
it will not. You just got to get burned. It's hot.
Oh,
Ooh,
it's
touch it, it'll go.
I mean, it's not super hot. You're not going to wind up with a burn spot. It's just getting warm. Put it this way. I'm going to use the towel to get it out.
So wait, what if you put your finger in that thing and you turn it on? Would you die?
What you do? Now, how about you break it?
It's not
when
hot,
really
really.
hot?
Huh?
If you break it when it's really hot, what's going to happen?
No.
No, it just shatters.
I'm touching it.
Is it?
Nothing comes out like
No, it
The
doesn't,
line
shoot sparks or anything cool like that. It just breaks.
that's tragic.
It really looks like if I touch it, it's not hot at all. I already touched it.
Oh, dang.
All right.
Like you don't need that towel.
That's breaking some flour in there.
Okay, stupid. You grab hold of it.
It
and
wasn't
squeeze
hot.
it.
I'm not gonna squeeze it, but it wasn't hot.
I need to get it out of there.
Okay, well then take it out.
Go ahead. Squeeze it and take it out for me. Without breaking
Yeah,
it.
don't
Yeah, I'm
break
gonna break it if you choke. Okay, I didn't know you had to look down. I thought
Yes.
I would have gotten it because I would have used my little thing. Look, see, look. All you have to do is use this. And then you push down.
Oh, is this a different color?
What's this one do?
This was nitrogen.
Oh,
It's the same color. or
I
different?
don't get it.
It's different.
It's kind of, but like the little two parts and stuff, they're different.
Yeah.
They kind of have that different.
This one, those look like fireworks. No, not really.
Can we buy one?
It's a lot of
Would we be able to get one at home?
Basically,
Why don't you turn it off first and then take it?
I was supposed to. I forgot.
Yeah, go ahead and shoot us.
All right.
wait, it's crooked.
It's cricket.
It's moving at the top.
All right. So
Hey, fix it.
that one is argon.
That's
All
what.
right. So I did hydrogen, nitrogen, and argon. But you get out of the way.
I was fixing it. You put it in crooked. What is this again? So what I have in my hand right now
I'm not going.
is I don't know. What is this? Oh, it vibrates. I have gas in my hand. You got that
All
gas?
right.
I've got that gas in my hand.
You put the call out.
Why is there this thing?
I don't know.
I
It's
think
probably got to do with when they sealed the thing in
How
the blue
come,
glass.
how come this one, like the little top, like the top of it kind of moves?
it was like that with the other ones.
It just does.
Because I thought if I touched it, like,
Alright.
lines would
Let's
shoot
try to finish
balls.
this.
That's what I thought it was.
So what do you see when light passes through a prism?
Color.
Rainbow, you see
All right.
this right here.
Now, this was Roy G. Biv. If we look at this, are we going to see Roy G. Biv? No. We're going to see,
Blue.
we're going to see these. Now, if we stay in here with all this visible light, we would. But if we had a dark room,
Turn it
and
off.
we, We still have all the windows open.
It better fit.
Evel, don't mess those blinds. They're struggling after 3 years. All right, but we,
Oh, wow.
I like it.
turn the lights back on. All right, we would see these line spectrum. Okay.
No, we wouldn't. You're lying. Let's go in a closet, put that thing in there.
You know, I've tried that for years, and every time I try it, people walk out and go, "I didn't see anything, Miss Wall." So I've quit. All right, so we would see something that's mostly black, and if we had hydrogen that was coming through here, all right, if we had hydrogen gas, we would see what? Hydrogen has essentially back out here, a blue, a lighter blue, and then a sort of a reddish down here. Okay? So, what determines the colors that we're going to see? What'd y'all say while I was waiting on it to reboot?
So we're saying like when an element goes through the prism?
Yes, when an element cruises through that prism, or when you use visible light that cruises through the prism. It doesn't matter which one we say. What determines the color that we see? Wavelength. Okay? It does not matter if it's visible light or if it's one of these. Wavelength still determines the color that we see through this. Okay? Now, did that one. I did it on that last board. All right, so why did the different colors? It just does. It's the home.
I used to have a lava lamp, and that reminds me of it. And then I broke it. My mom is, I don't think it's ever been more mad at me. Oh, that got all mentally. No, I did not. Is your husband okay? Stupid.
He's got to go to Baptist to have his eye looked at. He's got a tear or a partially detached retina.
Oh.
I don't think that's good.
No, it's probably not.
He's driving
Should
there.
you leave?
Yeah.
Insurance?
Yeah, we have insurance.
Is he driving there, or do I leave and I can watch class? Mr.
Well, yeah, how is he driving there?
Right.
When we
That's what we're trying to avoid. I'm going to talk to the office after I finish y'all's class. All right.
Hey, we were.
Good. Come on, write this down.
No, go ahead and leave, we got it.
I'm sure y'all do. Write this down.
He didn't want to show up to his class after lunch, and so he told me to go in there and like just like kind of like it was really funny. Yeah, I'll do it again for you.
He's like, I'll just drive up there. I'm like, let me get through second period and deal with the office.
Ooh.
Right, drive up there.
At least Beverly ain't
Are
here.
you done? Or are you
Yeah,
done?
with him.
Go ahead and get in that car if you want to.
Then we're going to have to worry about getting two cars
Now you're
home.
gonna have a whole different situation. Won't even be his eyes.
It'll be him in that car.
All right, so I had hydrogen in there, and hydrogen was what color? Y'all remember? The first one. It was a pink color. All right, then we had nitrogen, okay, a lighter pink. All right, and then we had argon. And argon was what color? That was the last one.
Gray.
Blue.
Light
Are you
blue.
serious, dude?
Blue.
All right, so why did I wind up with those three different colors? Why weren't they all the same? All right, so they're different gases. All right, but why would they have different colors just because they're different gases? All right, so they had different wavelengths. All right. All right, they had different numbers of electrons. All right, each have different numbers of electrons. And another one. What about the electrons? It's about the electrons. Electrons are not positive.
Photon.
It's got to do with the electrons. You already said they're different numbers.
Where they're at?
Yes.
You're so smart, girl. No, not. But
And different locations of the electrons.
aren't they all on the electron cloud?
That's what we're going to spend an enormous amount of time talking about next week to to the point y'all are gonna think I'm nuts, okay?
And
But
then you go on the exam, let me go.
Oh yeah, it's on the exam.
Okay.
All right. The part of the class, really all of next week, is on locations of electrons, and most of it is on the exam.
Wait.
Because they just do. And that leads us into the periodic table, which is a huge piece of the exam. Rosanna.
So, can they have the same electrons in different locations and still be different colors? Ooh, that's
Yes.
Or like
Yes.
in the same location with different numbers?
Yes.
Walk you over a little bit, please.
Yes.
Why are you answering
Well,
like
I'll
that?
drive your husband.
I was reading and listening at the same time.
So I can drive your husband. It'll get me out of third period.
I'm sure, but no.
You don't trust
First of all,
me?
I do, but no, you're going.
Car, so.
All right.
I'm having my car back now.
All right. I want to go to.
Must be not.
Sorry.
She said she got her car back. I'm just like, must be not.
Hey.
I feel your face, but
Where you
I
going?
don't have cars.
What she did was what she did when I heard her you ever lose it.
All right. Everybody got it? All right. I'm going to come back to Bohr on Monday and his theory. All right. We need to talk about this.
I'm always
All right. Find your orange chart. That's what we're going to finish with today.
Just throw it over there.
All right. Bohr's chart on the back page can be read in two ways. Okay? You can read it either going up the chart or down the chart. Do not write any of this on the charts. Okay? Write it in your notebook. All right? Now, there's two words we're going to use. We're either going to talk about emission or absorbed.
And this is labeled Bohr's model.
Then you can label it Bohr's model if you want, because we're going to be reading it off that. All right. Now, if we mean emission, emitted, that means we're going down. In number. Okay. So we might be going from like n equals 5 to n equals 2, because you're going from a ground state, or excuse me, the excited state down to the ground state. So if we're absorbing energy, we would be going up in number.
What does N stand for?
We're going to talk about that Monday. It means the energy level. Monday. Thinking about what's going to cost me to have his eye worked on.
I'm so sorry.
You got insurance? We don't cover it all?
That's not how that
Oh,
works.
no.
No, it is not. All right. So if we went from n equals 2 to n equals 5, we would absorb energy. All right. So
So go ahead to the office. We'll leave the bell rings.
no, I'll just call in a minute. Okay. N equals 5 to n equals 2, and n equals 2 to n equals 5. Now, we want to be able to read Bohr's model. Now, if I was to ask you for a color change, okay, or what color, let me find a chart so I can ask this. Let's say I want to know, what color is, the light emitted from n equals 6 to n equals 2. All right, let's say that's our question. Write it down because I'm going to change to the Bohr model and pull it up. All right, what color is the light emitted from n equals 6 to n equals 2? All right, do we all have it?
No.
Yeah.
All right, get it from your friends if you don't.
Oh my God. What was it? Is the light emitted?
Yep, from n equals 6 to n equals 2.
No.
You just said you were taking.
Whoops.
You said it.
All right. So on your chart, you have to find the arrow that reads from 6 to 2. All right. So if you look at this ring is a 6. This ring is a 2. You're looking for the circle and the arrow that lines up on n equals 6 and points to n equals 2. Okay?
I'm confused.
So this is on the 6. This is on the 2. So this bubble to this arrow lines up with 410. Now, here's the shortcut. 410 becomes 4.10. All right? 410 becomes 4.1. 4.1 sits here. So what color is it? Violet. That's it. Okay? Now, you still got your homework paper from last night?
Yes.
Let me tell you which couple you can't do.
All of them?
You cannot do question 20 because we've not done Neil's 4. You cannot do 21 because I forgot to draw a model, so you cannot do it because there's no model to look at. Okay? Otherwise, you can do the rest of the question. 20 and 21 are the only two you can't do. Okay?
Will you take it tomorrow, please?
I have four.
Who knows? Maybe I will.
If I ask my mom.
So we do 30 minutes.